How they say it's not the heat, it's the humidity. Folks, when it's 130 degrees, you don't care whether it's the humidity or not. And you'll find lots of other salt lakes out in the desert. They're known by the Spanish word playas. This is another one in Death Valley called the Racetrack. And they're formed by isolated lakes drying up. And sometimes we're there to see it, sometimes we're not. But there have been instances where lakes have dried up in historical times. So we can observe the process that gives rise to a thick bed of salt. Would I be allowed to teach this? Okay, all right, I'm good. In the 1970s, a researcher by the name of Kenneth Shue and his team started drilling in the rocks that lie beneath the Mediterranean Sea. The Mediterranean is, of course, between Europe on the north and Asia on the south side, and the Holy Land and its eastern border, excuse me. And drilling in these rocks showed the existence of massive layers of salt. You penetrate down into the rocks that make up the bottom, you go down a little ways, and you start hitting very thick layers of salt. And you find other minerals that, as far as I am aware, can only be produced by evaporation. Calcium sulfate is one, better known as gypsum, perhaps better known as plaster of Paris. A sulfur-containing mineral called anhydrite is also found in the Mediterranean Sea. There's a very good article on this in Scientific American for the year 1972. And minerals like this have only been observed, as far as I know, forming during the evaporation of water that is rich in minerals. Anhydrite, in particular, this calcium sulfate form, only forms in water that is evaporating, that's hotter than 95 degrees Fahrenheit. So the water has to be just a bit less than body temperature for this mineral to form at all. And it has been observed forming in desert lakes, in lakes called sabkhas, which are found in the Sahara and found in Saudi Arabia and found in other parts of the world as well. If the entire Mediterranean Sea were to dry up right now, the estimate that I've got is for every 1,000 feet of water depth should leave a layer of about 15 feet of salt if you're evaporating from salty water. If the entire sea were to dry up right now, it would leave a layer of salts a few hundred feet thick, and based on what we know on the physics of how evaporation works, it would take roughly 1,000 years to dry up completely. It would not dry up overnight. What Dr. Schuss found, who led the team that did the drilling, found that the salt and evaporite layers in the rocks below the Mediterranean Sea were many thousands of feet thick. His interpretation, and of course he is an evil secular humanist, so you should take this with a grain of salt. Oh, did I just say that? I'm sorry, that was unintentional. His interpretation was that the Mediterranean Sea has dried up repeatedly and been refilled. Even if you were to dry up all of the sea once and for all, it wouldn't leave layers of salt and gypsum and anhydrite thousands of feet thick. And his team and others have mapped the Mediterranean Sea floor. The black areas right there are areas where table salt, the salt that you are familiar with in your salt shakers, have been found. Other minerals that are, as far as we know, formed only in evaporation, like gypsum and anhydrite, are found in other regions. And you'll notice that they extend all the way over, sorry, the volume keeps going up and down, all the way over to the coast of ancient Phoenicia and Judea, modern-day Israel. If you take a boring instrument, me being a boring professor, I have plenty of those, and drill down into the base of the Mediterranean Sea using essentially the same technology that's used in offshore drilling rigs, you can pull out a circular cross-section of the layers of rock that you find once you get below the water level. This is known as taking a core sample. It's a very standard procedure. And at two different places, this is what you find. You find layers of sandstone, you find layers of a rock called diatomite, which I'll talk about in a moment, and you find several layers, 4 in the case of Greece, 5 in the case of Sicily, of salt separated by other types of rock. The problem is this: there are staggering numbers of fossils that are mixed in with these beds. Now, I am quite aware that fossils cannot ever provide any evidence whatsoever for evolution. The only thing a fossil can ever show you is that something died, right? All right, that's what you taught me last time. There are huge numbers of fossils of extinct life forms, things that we don't see now, that are mixed in with the salt beds. Some of these fossils are large. They are shells, mollusks, things like that. Others of them are microscopic in size. You're not likely to have heard of them, but people who do things like oil exploration will know of these forms called foraminifera and ostracoda and things like that. Now, we have huge numbers of fossils of things that we haven't found living today mixed in with these extremely thick salt beds, below them and above them. One of Dr. Hovind's excellent online essays states that bent rock layers, fossil graveyards, and polystrata fossils are best explained by a flood. I'd rather not talk about polystrata fossils and bent rock layers just yet, although there are some very nice bent rock layers in the road cut of Interstate 430, which is what I took to get here. But if fossil beds, rich in fossils of things that we no longer see alive, formed in the Great Flood, this must somehow mean that the salt beds did not form by evaporation. They must have formed in a flood. They must have formed in a great inundation, a great deluge of water. And they must have formed during the flood, but not during that entire time period. There must have been water in the Mediterranean before and after, or we wouldn't get fossils below and above the salt. Now, I can't find anything in Genesis that would, or Wallol, excuse me, bad spelling, I can't find anything in Genesis that would point to an event that would repeatedly dry out the Mediterranean Sea during the flood.